see NumPy selection and saving, and specifically selection we are going to see using inequality, which we missed in the previous video. Now let's see what NumPy selection that I am talking about. So let me first see if this selection what we are trying to see using inequality is possible with less, and then we compare it with the NumPy array, and we'll get some kind of understanding and intuition. So let's get started by creating a list lst using the range function, and I'm just simply creating a list of elements from 0 to 10. So this is what it is. Alright, so what am I trying to do? I'm trying to see if this kind of thing is possible with the list lst less than 5. It says less than is not supported between instances of list and int. So we can safely conclude that this is not possible. So of course, if this is not possible, I am saying this might also be not possible. Alright, so what am I trying to do? I'm placing this inequality in between square brackets, and obviously this would also be not possible, right? It says the same thing, so this is also not possible. Now why am I doing this? I want you to check on a NumPy array. Let me create a NumPy array using np.arange, and let me print it range, and let me print that NumPy array. Okay, and I want to do the same thing on this one. So you got this is your NumPy array and this is your list. So let me print this npa less than 5 and see what happens. Oh, see, look what happened is wherever the value is less than 5 it printed true, and wherever it is not, it showed us false. Now what about this one? What about this one? Inequality between the square brackets. Let me run this cell and see what happens. Okay, so it has resulted or given a NumPy array with set of values which are less than 5, or set of values which satisfy this inequality. Now what we have conveniently seen this for a one-dimensional array. Now how about a two-dimensional array? Let's try a two-dimensional array. Let's say ARR is equal to np.random.randint, maybe something like this, 49. What does this do? So basically it does it creates a one-dimensional array with 49 elements, okay, random elements with this range here. But anyways, I'm not interested in that. I'm interested to reshape this to a 7 by 7 matrix, NumPy array to be precise. Now this happens to become like this, right? Now what I want to do is I want to check this, print ARR less than let's say 75. Okay, ARR less than 75. So it says wherever it is less than 75 it prints true, wherever it is not it prints false. So here it is false because 78 is greater than 75, and so on. So it is very clear here. Now how about this, print ARR, and I'm using this inequality within the square brackets. What will happen is it will result in an array. Now the most important thing is, see, this is of shape 7 by 7, right? ARR is of shape 7 by 7. Okay, so if you check the dimension on ARR, it is of dimension 2. It is of dimension 2. Now what about this one? What about this array? I want to know the dimension of this. So dot ndim, this is the property that I'm going to use to find the dimension. So dimension of that is 1. So when you're using this inequality between the square brackets, you're simply getting a one-dimensional NumPy array. Alright, So this is one uh, this is the thing that we wanted to know or learn about the NumPy selection using inequality on a single dimension and a two-dimensional NumPy array. Now let's move on to saving a NumPy array. Let's say let's create a NumPy array. um, let's call it as x is equal to np dot random dot rand n 2 comma 3 comma 4, and let's print this x. What does this mean? All right, this is a two sets of 3 by 4 matrix. So two sets of 3 by 4 is like 3 rows, 1 2 3 and 4 columns, right? So if you want to check the x dot ndim of this dimension of this, it would be obviously a three-dimensional array, right? Three-dimensional array. All right, so what we wanted to do, yeah, we wanted to save this using np.save. Now what we'll do is np.save. all right, and we are going to use create your own name. So let's say I'll call it as arr underscore name. I want to save this to this name. And which one I want to save? I want to save x to this. All right, I want to save x to this. And then let me run this cell. What will happen? Let's see. So arr underscore name, and let me click on this arr. These are all the files, some other files that I have saved before. Arr underscore name. So np.save saves a NumPy array into .npy format. So saving to .npy format using np.save is what it says here. So that is what is happening here. Okay. Now if you want to load this file, there is something called as np.load method, which you simply say give the name here. What is the name here? arr underscore name dot npy. If you do not give the extension, it would not load it. It would not load it. So let me try this in a new cell rather than the old cell. All right, so let me run this cell. There you go, it loaded it. Okay, so this is how you save a NumPy array to a file in .npy format, and even you can load that file. Now if you want to do it in .csv format, you use something called as np.savetxt. So it is as simple as this. Let's say we are creating a NumPy array np dot random dot rand int 1 comma 100 and 49 dot reshape it to 7 comma 7. Okay, and you want to see, let me check this x. Okay, you have this array and you want to save it, so you use np.savetxt. you want to save it to CSV format, right? CSV format. Then what you say is save.txt and np.savetxt, and then you'll give the name. So let's give some name, my arr ay. All right, and you give what this is, x. Okay, and let's run this cell. So there you go, no, not this one, yeah, okay, let's close this and let's open this again. There you go, my arr ay. This is in .csv format. Okay, you can simply just download these files